back to the Integrate Intelligently podcast. I'm your host, Jeff Brickler. Once again, accompanied by my brother and founder of CADTALK Software, Scott Brickler. Scott, I know I've been traveling a lot. You've been traveling a lot too. Back home in Cincinnati, Ohio, and you in Northern Kentucky, of course. Mm-hmm. So glad to have you back in the original location.
Absolutely. It's so nice to be sleeping in my own bed again for a while. It's we do a few trips. I used to travel like 40 weeks a year, and I kind of remember how I used to do that. It was just this few weeks I've been traveling. These last few weeks has been maybe I just have to get old, right?
Yeah. Nothing says old and crotchety like complaining about traveling, right? And
Yeah,
not sleeping in your own bed. I was like, oh my God, I don't want to travel. Can't sleep in my own bed. I can't eat the food that I'm normally eating. Nothing says old and crotchety quite like that. We sound like a bunch of old men, it seems like.
Yeah. But it is nice to sleep at home. Actually, it's kind of a side note. Is like I used to have I have sleep apnea, so I had like a CPAP machine that I used to wear, and then this last couple of weeks ago, I actually changed over to like this dental appliance, and that's been a game changer. My sleep has gotten even better. We'll go down the rabbit hole of even like old man woes here. So
yeah, right. Getting worse. Some bald guys complaining about not sleeping in their own bed. I look in there like my gray beard and hate traveling, can't sleep, gotta sleep in my own bed, gotta wear this dental appliance so I can breathe at night. Gosh, whatever.
At least you could grow a beard, man. I can't grow anything. I am beard disabled. So
disabled,
or facial hair.
Facial hair challenged. Yeah,
there it is.
Yeah. Well, I mean, the alternative is that you can have a beard and be gray. So that's what I have. So
yeah, I'm sure it would be gray if I had one.
So Scott, today, like I said, I've been traveling a lot, and you have too. And so we're now back here talking about bills of materials again. Imagine that, I think today we're really focused on how important bills of material are for manufacturing. So Scott, if you don't mind, before we begin, I think kind of a couple of things. I remember I didn't come from manufacturing. So now, of course, I've learned all of that stuff. But for our listeners here, and, maybe for anyone who's new to manufacturing or new to this concept, can you give a brief overview of, bills of material? I think today's topic is going to be around mistakes in the bill of material. Can you give a little bit of kind of an introduction, like, what is a bill of material and like how, just at the basic level, how a mistake would impact anything?
Absolutely. I think I kind of recommend a book too. There's a great book that I think goes over what bills of material are and more and like a lot of detail. It's a short read. It's called Bill of Material Structured for Excellence, which is a great book. I think we can link that up in the show notes.
I wouldn't expect too many people to pick that page turner up.
No, it's definitely not a page. It's definitely not a page turner. It is for a geek like me who loves bill of materials and manufacturing. But it was I read it probably back in the late '90s. But it's a really good book, and somebody who you really want to go deep on bills of material. But the bills of material are essentially, I think of it, the best way to look at it is like a recipe for making something. So if you're just like you have a recipe for making cookies and you have the ingredients and you have the instructions for putting them together, there's a similar type of a recipe to put together anything in the manufacturing world. Like you have the parts, and the parts are made out of, assemblies are made out of parts, and those parts that are made out of raw materials, and they're made by some kind of either labor to turn the metal into a part, and all that comes together to make up how we build something. So the example I like to use a lot is your desk, your desk that you use every day for work. If the bill of material for your desk would be the overall assembly, which is your desk, is made up of a tabletop, maybe legs, the nuts and bolts that that are used to bolt together. Maybe like I have a standing desk, so like the motor mechanism, control module, the keyboard tray, all of those different parts would be that list of parts or a recipe to make a desk. And then you'd actually say typically in most time you'd have like a list of parts that makes up the assembly or whatever you're making at a quantity. And then if you really want to get detailed, like a bill of material will also a lot of times have like steps, just like in a recipe, it's like mixed together. You might have, with the steps, it would be assemble this part to this part. And then the other thing that's a little bit different about a bill of material as opposed to like a recipe. Typically recipes, we would call them single level bills. They're just one list of materials that you go together. Now, if you get a really complex recipe, you might have what we call multi-level bill of materials, which is we think about like a part. If I'm making an assembly, but then I'm making a desk. And then the desktop also has a bill of material being made up of maybe the wood, the plywood that you're going to cut, and then maybe the laminate material over top of it. That would be the bill of material for the tabletop. And that tabletop would then be the bill of material for the desk. So that's what we call multiple levels. And, in manufacturing, there could be, depending on the complexity of what you're building, you could actually have, tons of levels. I think 7, I believe, is the record, which I think it was a space shuttle, 7 levels deep. But most of the time, 2, 3 levels is about what most manufacturing companies operate at. But all it really is a list of things and a list of steps to put it together, just to give it like a recipe.
Yeah, one of the ways I always thought about it, I explain to people, my wife or my kids or people ask me, well, what do you do, Dida? Right? What do you do for a living? And I talk about, we talk about manufacturing bills of material. And they go, well, what is that? I think about it like the simplest way I think about it is like if you buy furniture from IKEA, right? You get that paper and that list of paper. And it's got the list of all the parts in it, right? Here are all the things that you need to put this together. And essentially, that's a bill of material. It's real simple, right? I mean, it is flat, but it's a list of all the screws, right? You said the motor, maybe the legs, the top, or any kind of furniture, right? The little locking mechanisms, cam locks, or whatever the pieces are that you need to put this thing together. Essentially, at the end is a bill of material. And when it comes in an IKEA box or it comes in a build your own kind of thing, it's not. We don't really think of it as a bill of material. We just think of it as like a parts list. But essentially, a parts list is a really simple bill of material. And then those instructions to build it is kind of like how you were thinking about like the operations, right? Or not all the operations, but that's kind of an idea of how it worked. At least my kind of puny brain of how I thought about it is. The simplest way that we interact with it everyday life is, buying IKEA furniture.
Yeah, that's a great example. I mean, the IKEA furniture, that's what I think that's something that everybody relates to. I mean, recipe, IKEA furniture, anything like that would be, technically the IKEA box would be considered a kit, we can get into a whole discussion about kitting, but like, because it's not assembled yet, like if you were selling the thing finished, then maybe it would be, it's still a bill of material, but the operation of assembling it hasn't been completed. Yeah, so left to the owner.
Yeah, outsourced. It's an outside process. Yeah. It's an outside process, right?
Typically Santa Claus on Christmas, or
that's right.
Okay,
yeah, right.
That's usually who's putting it together for you.
Yeah.
But yeah, the
dad powered.
Yeah, the dad powered, whatever that is. Yeah, you got it. So, but yeah, I mean, but like all it is essentially a list of parts, and that usually comes. And that's a lot of times when we do integrations, we're deriving or we're pulling that data from the engineering software. So if you're using like a SolidWorks or CAD software, the bill of material would be a artifact or a result of that design that you created in the CAD software. We can literally get that from that because inside of if you're using 3D modeling, what you're essentially doing is you're modeling reality, and then we can look at those individual parts and figure out kind of the bill of material from that. Now, we had earlier discussions about that. The bill of material coming from the CAD doesn't necessarily match the same way that we build it, which you have on the ERP side. So we have things called engineering bills of material, and then you have manufacturing bills of material, and there's some differences there. There's also planning bills of material. There's all different kinds that are used. And then there's all kinds of philosophies around what should be on the bill of materials. So if you read that book, Bill of Material Structure for Excellence, it provides an opinion about how bills of material and what should be on there. But there's a lot of variation with companies. I mean, some companies don't put things in like nuts and bolts. They figure those are consumable items. It's not really worth tracking. Some people put it all the way down to the washers and things like that, especially if it's important, like it is for like a space shuttle. So it just depends on your use case and things like that about how complete the bill of material is and what's needed based on that company's requirements.
Yeah, that's a good point. I've seen them working with hundreds of customers. I've seen all kinds of bills of material. Some where to your point, where like consumables, right? Could be nuts and bolts, could be labels, or even things that aren't on the bill of material at all. At least from a CAD perspective. And then sometimes even in the ERP, they don't represent them, right? They just have like kind of Kanban or Kanban buckets, right, where they just pull stuff out and then they just write them off. And so write them off or use them, just expense them. So I've seen that as well. But I also think about like, since today's topic is about, common BOM errors, BOM errors and their origins, I also was relating that back to if you've ever had to build something, like you said on Christmas, or for your kid, or you're building something out of IKEA furniture, how frustrating it is when you get the list of parts and you're missing parts, right? Nothing worse on Christmas where your kid wants to play with this new toy, you don't have batteries, or you don't have parts, or they can't play with it because you don't have everything you need. That's a mistake on the bill of material, right? That is a real life incident that someone can experience, a BOM error.
Oh yeah, I mean, like batteries not included, right? Yeah, an interesting side about that. Like, it used to be, obviously batteries weren't included. So like when we were growing up, it was inevitable that a parent would like buy something and you open it up on Christmas Day, and then they forget to buy the batteries to go with it. And then you see nowadays, especially with people, they package the batteries now with the toy, so you can play with it immediately. And the same thing translates to like rechargeable batteries. It's one of the things that I think Apple started this with the iPod. They actually charge the battery up, so it's ready to use when you buy it. And the reason they do that is so there isn't any loss of people can start using it right away, and you're not losing 3 hours trying to make sure it's charged up before you can use the thing you just bought. So it really is trying to delay that. So, but just a really good point is that batteries not included. It used to be a big thing when we were growing up, and now all that's basically a more complete bill of material makes for a happy Christmas.
That's it, right? Yeah, and no unnecessary trips to the hardware store trying to get the pieces that you need the day after Christmas, so you can make your kid happy, or that you can do whatever you need to do. So that's a good kind of analogy, or at least real life use case that people would understand who don't work in manufacturing, where a mistake on the bill of material. If you ever had a crying kid on Christmas because he can't play with his toy or her toy, a real life example of a mistake on a bill of material. Now, of course, in manufacturing, it's not quite the same, but I think the result's the same. Maybe the baby's not crying, but like somebody's crying.
A crying shop foreman.
Yeah, crying shop foreman. Yeah. Or a customer, God forbid,
or customer,
right? It gets all the way to the customer and something's missing, right? Bolts are missing or parts are missing. So thinking about that, what are some common issues or common mistakes that happen on a bill of material, and what causes them?
I mean, a very common one is just leaving things out, like you mentioned, or especially with that's less of an issue. It's still an issue, but it's less of an issue with solid modeling. Like back in the 2D CAD days, it's just easy to miss things, right? If it's not dimensionally there, it's not something you need to have in the drawing to show, then it tended not to come across. So you have to do more manual interaction of like, did I draw this thing? Like the creation of the bill of material and the creation of the drawing were like two separate things, right? You might create the drawing, but then create a bill of material on there. And when we started going towards true models or entities in the CAD design, that became more synonymous. You're designing a virtual representation of that thing in 3D space or even in 2D space. And then it's easier for the software to kind of recognize that entity and count it up and create a bill of material on the fly. Still, just the idea of like forgetting things or like leaving things out, like hardware or glue or things that you need because they're not visually seen in the tool, could lead to a lot of issues. The other thing would be like metadata or things around that, like picking the wrong materials or not putting enough data in there around it, and then then that doesn't get translated really well into the manufacturing bills of material. So that's part of like the translation process that we do as well. But it's just leaving things out or picking the wrong data, or like maybe choosing the wrong vendor or things like that, or choosing the wrong quantity. So say there's a really expensive part in the assembly and you put 3 instead of 2, and then you're buying it, maybe it's $50,000 a pop, and now you're going to spend $50,000 more than you thought you were so all of those things, kind of the quantity issues, the missing parts, just metadata, things like that are missing. It's usually missing or incorrect data that just drives everything haywire. Because if you think about an ERP system, which is the driver of all the manufacturing in a manufacturing company, it does all the MRP, it orders all the parts, it does all that stuff. The base data that it works with to do all of that is the bill of material. And if that thing's off, then everything's off down the stream. So think of it being like you start with a crooked, have you ever done tile floor? I know we've tiled floors before in our past. Like remember we had that apartment building together and we were like tiling the floor, and I think I tiled the first tile crooked. And then in the kitchen, and then all of the tiles are crooked in the kitchen. So it's like, you look at the walls, and the walls are like straight, but then the tiles are going like this, or they're like this. And because you started with a bad tile that was crooked, and then all the other tiles span off of that crooked too. Let's say you're similar with the bill of material. It's the first tile in the lit in that, and then and everything else in the ERP is kind of off because you got that
magnified.
It's magnified.
The problems are magnified. Right. Yeah. Exactly right. That's exactly right. I was thinking about, you're talking about like we have less of that problem back at, when they had just AutoCAD and they were creating line drawings, essentially digital draft boards, and then they were creating a bill of material manually, either in the ERP or even in a spreadsheet or something, right? And then handing that to the shop floor. We have more mistakes. But I think about like even today with 3D, yeah, you can export the BOM in Excel, but essentially you still have to, if you're going to transfer it manually, you still have to deal with that kind of manual transfer, with that risk of losing an item on the bill. Not to mention things that aren't in the CAD that you have to remember to add, right? Like you said, paint or glue, or as we joked earlier, outside processes, right? Like if you need to send a part out to be galvanized or plated or powder coated or something like that, you got to keep all that in mind as well. So if you're doing all that manual, very common that you can miss those steps, or you have to spend a lot more time. What one of the guys here at CADTALK told me one time, stare and compare. You spend a lot of time looking at this sheet and this sheet, and then going back and forth, and just one by one making sure you have everything, and having a checklist. Whereas much higher risk of failure in terms of qualities of bills of material, but it's not just the straight kind of parts, right? It's also all the other things around that, like adding raw material, adding raw outside processes, adding paint, right? And then calculating the material, or even setting things like units of measure. I was on a call recently for a demonstration, and a customer asked me about like units of measure, I guess because they were having troubles with unit of measure in their ERP with raw material, and how they had it, like where like they had a sheet or something, and then they were misordering the amount of material when it said like they needed 3 of these, and they thought like 3 sheets, and it wasn't really 3 sheets. It was more like 3, or it could be sticks or whatever, right? 3 sheets or 3 sticks. Like the quantity of 3, if you don't have it set up correctly with the right unit of measure, then you're going to end up ordering 3 sheets or 3 sticks of something when you need 3 inches or 3 square inches or something like that. You really got to be careful. It can really mess things up, right? Instead of ordering 1 sheet or 1 stick of bar stock, where you only need 3 inches for it, right? Of a 10-foot stick. Now you order 3 10-foot sticks. Well, I didn't need 3 10-foot sticks.
Right. Yeah. And those are the hard costs. I mean, like if you think about, like we'll probably bring up we have a calculator on our website that kind of helps justify, like an ROI calculator for CADTALK, but like, which goes into some of the issues you see with like typical, cost of bill of material. Like the most common thing people talk about with ROI is like time savings, because you don't actually have to do that work, which I think is actually it's less interesting.
It's the least important thing.
It's easy to measure. So like a lot of times with people do ROIs and things like that, there's things that are easy to measure, but not necessarily the most important. And usually the soft cost things that you get into are typically where the real cost savings is. It's just harder to measure. So people don't look at that as much. But like the soft cost of, let me define like hard cost versus soft cost. Like somebody's time is a pretty hard cost, right? The amount, like a mistake is kind of a soft cost, or it's kind of a hard cost. You can at least quantify what a mistake costs, but like some mistakes are bigger than others, right? So it's a little harder to put your finger on, but you can at least put a value around that. But one of the things that's like a soft cost, we're like, well, how much improvement do you have if all your bill of material data is pretty accurate, or at least consistently wrong, which we talked about that in the last episode. Better to be consistently wrong than sporadically right. If it's consistent, what's the value of being able to use your MRP more effectively or your ERP more effectively? What's the value of having more effective scheduling? What's the value? Those are all soft costs. So a lot of times, I think one of the ones kind of underutilized, or one of the undernoted benefits of having an integration like this, or having these bills of material be consistent and accurate, probably more consistent than accurate, but having that in place is all of these side benefits and the realization of the benefits you originally bought your ERP for. And those are soft costs, are hard to measure. It's like, they're nonetheless very, very, very important, and they're very material. But like I said, the hard costs are the ones that people really understand and they grasp onto. But just think about, for everything we talk about as a hard cost, there's probably, you know, 5 or 10 times more important soft costs right behind it.
Scott, we're showing right now our value calculator, or kind of hard cost calculator. So as you mentioned, you know, there are two kind of costs associated with mistakes on the bill of material, both what we call hard costs, which are time and money, really money, right? Time savings from an integration or an automation solution like CADTALK, and, you know, reducing mistakes on the bill of material. So we'll kind of go over what we call an ROI calculator to figure out like what are the hard costs. Soft costs, as you mentioned, much harder to calculate. What's the value in having things run more smoothly, having a better bill of material for better MRP, better scheduling? Very hard to measure those things. But of course, anybody who knows, you know, kind of knows systems and how systems work, if the upstream quality is not good, right, the downstream is not going to get any better. So Scott, I think let's look at this ROI calculator and kind of work through here some possible scenarios. I think, Scott, you know, I think originally when I first came to CADTALK, you had built one of these in Excel to help educate people on, you know, the value of an integration. So can you talk a little bit about, like, let's think about that. I think the first thing is to calculate the time. So hourly cost of entering data. I think I usually used, you know, I think I used about $50 an hour on this, I think, originally, with depending on who's going to do the work, if it's an engineer or if it's someone in operations, a manufacturing engineer or a design engineer, plus all the burden rate, the cost of actually paying for that employee, right? We always estimate about $50 an hour. Does that still seem true, or does inflation get us and it's even more now?
Yeah, it just depends on who's doing the work. Generally, I mean, a lot of times we see this as engineers themselves doing it, which is probably the worst case scenario. And then you have even a manufacturing engineer, which is because there's a lot of times there's routing data and things like that need to be done. So people a lot of times will try to underestimate this number. It's like, oh, it's just a data entry clerk or somebody who's not that expensive. But the problem is that you're kind of underestimating there's knowledge being relayed here somewhere, right? And that a lot of that times that knowledge can be derived with a tool like ours, but it's not just a key punching thing. It's more of some key punching as well as some augmentation with some knowledge. So a lot of times it ends up being somebody who's a little bit more expensive, like an engineer. And the burden cost is a really good statement, because if people always think, well, what's the hourly rate of that person? You know, what they make per year? But it's typically, we're doing budgets right now, and I'm seeing this even today, is that there's health insurance, taxes, you know, like I think all these things, especially
401k, there's all these benefits.
Yeah. So things cost a lot more. So an average engineer, you think like a $50 an hour is a $100,000 a year job. Like today's world, I mean, a lot of engineers make more than that. Yeah. So it's like $75 an hour is probably even a better estimate if you're thinking about a true, you know, engineer with any kind of, and you got to average that across junior to senior, right? So we can go with a pretty good, you know, $75 an hour. Another, just before I forget, another soft cost that I think is really important that people typically gloss over because it's really hard to measure the benefit of is lead time reduction. So if you think about automation or those types of things, the time it's something bills of materials spend or things paperwork spends on people's desks waiting to be done is lost lead time. So you're actually, every day that it sits there is a day you didn't deliver it to the customer. And what does that cost? So a lot of times trying to reduce lead time is almost a better proxy for overall cost than actually measuring cost in a lot of places. And there's a whole caveat about that called quick response manufacturing, things like that. But just as a side note, the lead time reduction is also a very, very large soft cost that people don't realize.
Yeah, I always compare that to the Amazon, right? The 2-day prime shipping. So I always say, like, it's not exactly the same, but like I think about like how much value is it for me to go into Amazon and to click a button and get it same day or next day, right? Huge amount of value. It's not the same idea. It's not the same exact process, but similar idea in the sense that like there's tremendous of value in reducing that lead time. How much time does it take to get from me ordering it, which is what happens, you know, when a customer is waiting on their product from manufacturing. The time I want it, I say, yes, go get it. The time I get it, that's the lead time. Anything you can do to reduce the lead time, you know, improves, you know, the outcome for the customer. And that has its own intrinsic value.
and typically increases sales. That's why Amazon does it, right? They do lead time because it increases sales. People are willing to pay more and buy more if they get it faster. That's just true, right?
Proven by Amazon every day, right? We'll pay for Amazon's Prime, right, to be able to press a button to get it the same day or next day. I mean, so many people, reducing lead times for manufacturing companies, it's the same, right? It's the same, increasing sales by getting it to your customer faster.
Absolutely. Yep. So very important, hard to measure, a true benefit and cost nonetheless. So.
Yeah. I mean, you can't argue with Amazon. What is it, $1 trillion company? And a big part of that is that Prime was a huge driver. Okay, so enough about those soft costs. Let's get into these hard costs here. So we're saying about $75 an hour for a data entry. If somebody doesn't believe us, they can, or that likes what's different value there, they can certainly go into the website calculator, CADTALK.com, and then change that $75 to something else. Maybe it might differ for your area, your region, right? I should mention we have customers all over the world. This is in U.S. dollars, so you have to put your equivalent in U.S. dollars. Number of items created each month. So Scott, when you were working in manufacturing, you worked at an engineering to order company, but CADTALK works for more than just engineering to order. But what do you think is a reasonable number of new items per month, or what did you experience when you were doing it?
It was obviously the extreme of the extreme when I came from. So I think it was 3,000 new part numbers every month is what we created. Now that's probably not most customers or most companies, right? So it just depends on the flow of that. But it was a ton of new parts that we created all the time. If you have 150 engineers designing all day, you're going to have a lot of parts, a lot of new ones, right? But I think for a normal company, a few hundred is probably a pretty good, estimate. I don't know if you have one on top of your mind that you would go with.
Yeah, I just think about probably the number of engineers they have, right? So if you have one engineer, you're not going to create that many. But if you have 15 or 20, I think that easily you're going to get 500 or 600. If you have 15 engineers, you easily, 10 a month, right? That's would be 15 engineers, 150. So I think 300 part numbers is a reasonable estimate in terms of creating new ones. And then the amount of time to enter those, right? So how much time does it create to enter a new item? I usually use 15 minutes for this to go from from start to finish. Some people will say, "Why? I'm really fast at this. I can really do it really quickly. I can do it in 1 or 2 minutes." I think, 15 minutes from the whole opening the browser, logging in, getting in there, doing all of that. So
it really depends on what you're doing too. If you're attaching drawings, are you going and doing pricing? Are you doing vendor information? It depends on what all that is. And so, so I think that's a pretty good estimate there.
Yeah. So 15 minutes. What's the next one? Number of BOMs per month. Is that bills of material? So this is not just items, because you got to remember when you're creating a bill of material, you got to create items, but once you create the items, you got to create the bills of material. How many, is this just new bills of material? Yeah. How many new bills of material are created?
Well, technically every manufactured part that you create has a bill of material, right? Even it's just one part. If it's, then there's assemblies on top of that. So I would think a good estimate would be, anywhere between 50 to 75% of the new numbers would be,
So maybe 100,
150.
BOM errors. Yeah. So I think before we go on the BOM errors, we should probably include the 150. It could be edits too, right? Updates, not just new, but updates.
Right. That's below number of changes.
Okay. I didn't see that. Okay, good. Changes. Number of BOM errors. So what do you think is a reasonable 10% errors? Is that reasonable if you're doing it manually?
Yeah, it's hard. It's like you said, and the cost of that's hard. But let's just go conservative and say, we're humans and we mess up. We mess up 1 out of 10 things. That's
right. Not we're 90%. We're not.
Yeah.
And then number of changes per month. Now this could be a lot. It depends. I know one of our customers does probably hundreds of changes a month. Hundreds.
Oh yeah, sometimes more than what they like. I know when I was working in manufacturing, we had just as many part numbers and just as many engineering changes, so they're equal. So yeah, if you wanted to go with 300 changes to kind of make it equal, I think that's some people, it depends on the business. People might debate with us on those numbers, but once again, you can put it in yourself, right? and then check it out. So these are just based on our experience. Yeah. All right, amount of time to enter update bill. It really depends. Like I think sometimes changing things is actually a little harder than making them.
Harder.
Because you actually have to make more distinctions about what something is. So you have to say, is this still here? Is this not going to be here? Like what's different? So I would go, 20 to 30 minutes for a bill of material change.
Yeah, I would put half hour. Yeah.
Yeah. So just hard cost. I mean, obviously people would debate with us maybe about some of our numbers, but you can see like, monthly labor costs about $23,000. If you could save 80% of that, like I think if I'm looking at this correctly, like that's what it would cost, I believe, with CADTALK. So if you had some kind of automation in place, that's then we're saving 80% of the time, which is pretty common actually for us to do. Then that's what that would be. That would be the actual cost. I think that's correct. That's the cost of what it would be once you had CADTALK in place. So yeah. Yeah. And then and sometimes we actually automate it 100% because if they have we call a service-based host and things like that, it actually even gets more than that. Which actually is a good caveat. You think about if we can save 80%, it's only manual. That last 20% could be a huge amount of work for very little benefit. So as you can see right here, but nonetheless, that lead time reduction, that soft cost really comes into play when you start completely automating it. Annual labor cost, that's what it costs, and then the 80%. So the cost savings annually, and then also with CADTALK or some kind of automation in places down below. So that's pretty huge. I mean, typically the ROI, depending on what you're buying from CADTALK, what our costs are going to be significantly lower than that. So usually, the automation itself, just on the hard costs, makes it pretty easy to justify, right? It's pretty easy numbers. If you start thinking about the soft cost, then it kind of becomes really just a no-brainer. I mean, it really does. It's why, it's so popular to do this. It makes so much sense. Anything you want to add on that, Jeff, or?
Yeah, I mean, when I've usually done this in the past, people might say, well, it doesn't take that long, or they don't make that much money, or you're not going to save 80%. And I think, well, even still, right? Let's say I'm not saving 80%. Let's say I'm only saving 50% or 40%, right? You're still talking about a huge amount of savings, a huge amount of benefits in hard costs. So like you said, it becomes a pretty no-brainer. Not to mention that the quality of work is way better, right? So you got to think about that soft cost of entering something manually is not exciting. It's not exciting. It's not going to get you up in the morning like, yes, bills of material. I'm going to enter bills of material today. I'm going to enter this, 1,000 part bill of material. I'm going to take me all week. This is the best week ever. Like no one goes to work thinking that. So I just think about the job satisfaction and the quality and what you can spend your time on if you weren't doing that. So it's not that soft cost includes, yes, lead time, yes, more sales, but also employee satisfaction and focusing on other tasks that would be way more valuable for the company. Again, soft cost because you don't know, but if you're improving the quality of the data, you're improving the process, and those folks enjoy their job better, are more challenged with other projects that they find more engaging than entering stuff manually or making manual corrections or putting out fires because of issues on the shop floor, way better use of their time than anything else. So I think we can't discount that in the soft costs. Because of course, entering bills of material, there's data manual. I don't think anyone enjoys that, right? Keying in any kind of data manually. And so,
yeah, I would say another common argument we see a lot of. I actually used to have this with a colleague. He'd say, "Well, if I only save 50% of one person's time, it's not like I'm going to let that person go to part time and only work 50% of the time. I still pay for them." And that's a common kind of misconception with time savings is that, we have that great, that book that we follow, Buy Back Your Time. We talks about that. And it's like, that's kind of a common, complaint. It's like, well, if I save 3 hours, I'm not going to stop paying that person that 3 hours. I still have to pay for them. So where's the real cost coming from? But it actually does translate really, really well because that opens up the opportunity to fill it back up with more valuable work.
That's right.
Right. And then you're always leveling up for more of that work. So one of the things that we talked about before is like, if you're just busy all the time trying to just get the bills in or just trying to get some kind of thing in, just something that's more administrative done, then you don't have the bandwidth to even think about a better thing that you could do tomorrow. You're literally just trying to do the thing you have today. Every time we free up that time, it's another soft cost. Every time you free that up, then the opportunity for that person to then come up with a better idea or to improve a process or to do something or like go out in the shop floor and see an opportunity that would save even more, that opens up that possibility. Whereas in the past, everybody is working at full capacity doing these things that are kind of administrative. You'd have to add people or add staff to even talk about doing that, which is very difficult to do if you run businesses, which I do. So I understand exactly how much that is and how hard it is to do that. But if you can free up your already highly skilled and highly experienced people in your business by removing some of these administrative things, and it opens up the possibility of letting humans do what humans do best, which is come up with creative solutions and improve the business as opposed to doing administrative work.
No, that's a good point. Yeah, looking at that, what they call, I think you mentioned that kind of the idea of buy back your time or giving yourself more capacity to look at bigger problems or other problems that you wouldn't do, right? If you're just so caught up in doing the day-to-day tasks, you're never going to try to solve a bigger problem because you don't have the capacity. Like, why would I bother even looking at this? In fact, your mind's not even open to looking at that because you're so consumed with what you have to do. Getting that bandwidth, allows a person, an engineer or someone who's really keen on solving complex problems, be able to have that go, you know what? There's a problem over here. Let me see if I can figure that out. And having that bandwidth is definitely helpful. It's hard to convince people of that, though. You're like, well, if I give them more time, they'll spend more time doing nothing. And I think better of people then. I think really, people will find and improve things if they have the capacity to do it.
I mean, most time and things are burnt in task switching and communication.
Yeah.
Right. So I think about the value of automation, right? Or like actually time savings. So you think about like, there's this book it's common in development world called the Mythical Man Month, which is like, well, if I have 100 hours worth of development to do, I can have, one person, it takes 100 hours. And then if I have two people, it takes each person 50 hours. And if I have three people, it takes each person 33.3 hours, and there's just like, well, if I could do it, if I get 100 people to work for an hour, I get this thing done. And we all know that's ridiculous, right? Like the math doesn't math like that, right? It doesn't really work and why is that? Because of communication costs. The communication cost is actually to communicate across all of those people goes up. It's pretty much like a logarithmic curve. It actually goes up pretty quickly, so you actually can almost have more time depending on the number of people you actually add more communication costs in the task itself. So like in the development world, the fastest you could ever code something is with one person, not from a lead time perspective, from a total time perspective. And what you're doing is you're just trading lead time for actually more. It's going to take more time. So say it took 2 developers, it might take, X of what it took 1 developer, but you're going to get it, faster. So you're always making those kind of trade-offs. And the same thing happens with task switching. If I'm an engineer and then I'm designing things all day, and then I have to decide, I got to stop and then get all the stuff into the system so they can do that, so it can be done. So we can start making something. Then I have task switch. So I have an inefficiency that comes from task switching. I was designing, now I'm doing this thing. Okay. And you're like, well, just get somebody else to do it. Well, then there's the communication cost. I have to then figure out how to communicate the thing that I did to the other person and in a way that they understand my intent. Whereas if you have automation, then that cost of communication and the cost of task switching goes down because you're able to communicate the intent from the design phase, and you're also able to cut down on the task switching because you don't have to task switch as often because you can do them either you can batch it or it can be completely automated, and then you can continue with the flow of doing the work that you're doing. And so eliminating task switching and reducing communication costs actually reduces the total time it takes to do something without consuming that person's time.
Yeah, it's a good point. I mean, like, it sounds like the soft costs. I mean, again, right, it's so hard to measure those things. And which makes it less believable. This in my conversations, people believe it less, right? They just go, oh, well, that's kind of hand wavy, but those things really do matter. They really do matter, and they really have a huge benefit. Just hard to measure and sometimes hard to justify to someone in business, right? But if you understand systems, and when you worked in companies, the cost of communication and the cost of the task switching is a huge cost, especially in today's world with all the different things people are asked to do. So, we saw today that, of course, the bill of material mistake and the manual entry can be hugely expensive, right? And the benefits of doing some kind of automated process or some semi-automated process with an integration like CADTALK is going to be hugely helpful. Just improving that process overall is going to improve, the soft costs. There's both hard and soft costs. So hard costs of actual time and money, reducing errors, speeding up the process, fewer hours, but also the soft costs of, lead time, task switching, other process improvements that the business could get from, better employee satisfaction. So those are kind of all the things we talked about. Anything I missed or anything else, other key takeaways you have, Scott?
No, I think it's, I think any project you think about, I remember doing this in my MBA, talking about like the present value of any investment or project that you would take on in a business and things like that. And you figure out hard costs, and you'd be able to you figure out the time value of money, like $1 spent today is worth more than $1 tomorrow, things like that. But I think when you look at something and you're looking at a model to figure out if you should take an action or do something, that you're investing money, which is what you're doing. You're investing money in any of these solutions. Is that like one of the ways I like to look at it is maybe even come up with an idea of what the soft cost could be. If you can justify it with hard cost, it's a no-brainer. I mean, even they tell you that, like I was getting my MBA, anything that has a net present value, like that's positive, you should do it. Based on risk and probabilities, those things are going to happen, right? Because life doesn't happen exactly the way you think it should. There's a probability matrix of that, right? But if you think about something being that you could prove it with the hard cost, you're probably going to see I'm guessing maybe 2 to 5x on soft costs that you can't even measure on something like that. So, I think people should be a little bit more bullish on some of these things, but realize, and just, but also take into account, like, what's your probability of success in any project? As the project gets more complex, your probability of success goes down, and then then realizing those benefits goes down as well. So you're always kind of measuring. You're always going back and forth and measuring these different levers. The more complex you try to do it, the more chance of failure. So you're just trying to balance and optimize to get the most return on your dollars, just like anything else.
Yeah, Scott. Just wanted to, say thanks for joining this call. I'm glad, as we joked about, being glad to be back home and have this conversation. I think that about wraps it up. So good discussion about, hard and soft costs in terms of ERP integrations. I encourage any of you to go to the website, to the CADTALK.com, and look at the ROI calculator, put your own numbers in there, play around with it, see what you think. Feel free to do. That's a tool that we want to provide to help business people, operations, managers, engineering managers really look at the time that their teams are spending on that and what the value and return of that return would be in terms of an integration solution. So, Scott, until next time, any last things to say?
No, I think it was a great discussion today.
Sure. Yep, Scott. So thanks a lot. So we'll see you next time.